Hello students, hello viewers. In this video, I am going to demonstrate how to use on-delay timer relay in controlling the hydraulic and pneumatic movements, cylinder movements. Uh, so on-delay timer, uh, it is looked like this. This is a relay, on-delay time relay. Uh, it working is same as the normal relay, but it is having the timer circuit. So timer circuit is nothing but RC circuit, resistor and capacitor circuit is how it's shown here. Here you can see the variable resistance here. So by changing the resistance value, the time taken by the capacitor will be changed to charge completely and supply full voltage to the coil. Okay, so relay function as explained in the classroom or earlier videos. Whenever coil is energized, open contact become closed, closed contact become open. That is called changeover of contacts. In simple relay, whenever coil is energized, this changeover of contacts will happen immediately without any delay. But in time with the relay coil with timer circuit, is like there is a changeover of contacts after a certain delay of time. So there is a changeover of contacts after delay, so it is called switch on delay timer. It will take delay to switch on or switch on the changeover. That's the concept. If you refer this timing diagram, it will be very useful to understanding the on delay timer. It shows that, see, this is the input, this is the input, this is a contact is the output actually. So when you supply the voltage to the coil, that is whenever input is high, immediately there is no output. Okay, so it is waiting for the time. How much time? That is small t, that is the delay time. So after the delay, then only output is on. That means changeover of contacts. So contact will change over from close to open or open to close after delay. So whenever input is off, that means whenever you cut off the supply to the coil, again contacts will go to the normal position. That is called the output is low. When input is low, output is low. Okay, so this is a representation of on delay coil. See, simple coil, there is no cross symbol. On delay timer, to indicate that there is a cross symbol in the coil. That's the indication. So physically how it looked like in the laboratory. So this is how the relay module will look like. It is having one normally open and one normally closed, and the cross symbol indicates that it is a switch on delay. And there is a knob here to change the resistance value. So that is, if you see the specification here, time can be adjusted from 0.5 seconds to 15 seconds. That is the range of this module. So in the laboratory, we are going to rig up one circuit to understand the application of on delay timer, and thus that circuit I am going to demonstrate building in the Festo Fluid Sim software. Double click on the software. This is a demo version software. Go to the new file. Here directly I'll go to the electrical control IEC standard. Power supply is 24 volts. The relay module operating voltage is 24 volts. And if you take the switches, that is relay, the switch, I'll take one simple normal open switch, and I'll take the relay, that is, yeah, relay with on delay, relay with switch on delay. And the name of the switch I'm giving as S1, and the relay name I'm giving as KT. That means it's relay but time relay. Now I'll take one contact. Time relay is having normally open as well as close contact. I'm taking normally open contact, and then I'm connecting to buzzer. I'm taking one buzzer here, and this I'm linking to KT. And here delay by default is having 5 seconds. I'll change it, double click on it. Okay, change it to 10 seconds. Now go to the simulation. When you press on switch S1, it is counting the time. After 10 seconds, buzzer will be on. So this circuit, same circuit I have rigged up in the laboratory, and you follow this, you follow the lab video after this screen recording. Thank you everyone. Please continue the video to understand the lab video on delay time relay. Thank you. Hello everyone. In this video, I'm going to demonstrate the working of on delay timer. So here the electrical panels is there. So this is a distributor where we can take 24 volts and 24 volt DC supply, and this is a switch module. We have got 2 push buttons and 1 toggle switch, and then there is a on delay relay. This is on delay relay, the symbol, which is having one normally open and one normally close, and then this is the indicator box where 4 LEDs are there, four LEDs are there, and one buzzer is there. So now positive, negative. We are now taking the power from SMPS to the control panel. SMPS, it is available here. So this is SMPS, which converts single phase AC into 24 volt DC. So this is a 24 volts DC. So that power is taken from SMPS to the distributor here. This is a distributor. So this is a 24 volt line. And this is a negative, or ground is taken from the SMPS and connected here. Now 24 volts is available here. Now what I'll do is, using a so this is a 24 volts line, so I'll take one point and connect it to normally open switch. This is a normally open switch, and from normally open switch we can connect it to on delay relay, that is A1, that is positive, and A2 of on delay relay is connected to the ground supply, ground. And to see the output from the on delay timer, I am using now that is normally open contact. That means 24 volts From 24 volts we can connect it to normally open contact of time delay, and from a normally open contact to output we can give it to buzzer or LED. I'll give it to buzzer first, and to complete the circuit, the load, the buzzer is a load, so that is connected to the ground is pending, ground wire is pending. So this ground wire I am connecting to, here already ground is there, so I'll put it here. Okay, so this is a simple circuit. This is a simple circuit where, so we are going to switch on the main power. Now I'm going to switch on the switch. So now you can see that time delay is on. That means after delay you are getting the output. I'm using push button here. So the thing is that when input is high, immediately output is high, and it will wait for the time so that contacts will get changeover. So I'll change the load from buzzer to LED, and I can increase the time here. Maximum time is 15 seconds. Approximately I've given 5 seconds. Now I'll press the switch and hold it for 5 seconds. After 5 seconds, output will be on. Right? So in industrial applications, this on delay timer can be used to control the door control, or even in pneumatics also, cylinder can be extended after the delay or can be retracted after the delay. So the process involved in time, so that can be completed. So this application of this timer, time relay, on delay time relay can be used in hydraulics as well as pneumatics. And on delay requires a continuous signal, at least for the time set in the timer. If you just give a pulse signal, your timer will not work. Even after 5 seconds, you will not get the output. So it requires a continuous signal, at least for the time set in the timer. And this is a knob, you can adjust it from 0.5 seconds to 15 seconds.